Hey guys, this is Bruce coming at you from Groxio, and we're going to recap what you learned in the Pony segment. So we started pretty basic, but even this simple Hello World program gave us a lot of information. The actor shows you that Pony is an actor-based language with message passing, and you can even see in that first constructor that it's a little different. You can see the new create. New means that the next thing that comes is going to be a constructor, and Pony has named constructors. So the first one is called create, and the second thing that's pretty cool here is that Pony is fully typed. You can see that in the first env and the second env. The second one is a type, but Pony is trying to implement what's called a closed type system, and that means the intent is that any time that you step out of the type system at all, Pony is going to try its hardest to throw a compile error. In fact, there's a proof to say that Pony is type safe. And the other thing that's cool about Pony types is that they don't stop with the structure of the thing in the type. Actually, Pony types include something that's called a reference capability. And a reference capability basically determines the rules that safe concurrent programs need to follow. So if you're doing something that's not safe with the variables in your program won't compile. So this next program is basically giving you the sense of how far Pony is willing to go to become safe. So the last line in the program, in fact, the last little expression in the program, that array 0, that question mark means that this is a partial. And partial in this sense means that this function can have a behavior that fails, and it's up to the user that calls this function to express the failed behavior within the else clause of a try statement. So if this isn't in a try statement, it's not going to compile. So this won't compile, and you can make it compile by surrounding array in a try end. And actually, if it fails, then Pony is just going to unwind the stack and rebuild and work forward from the else statement or the default else, which is a none implementation. So the next program that we saw was a safe counter, and this is pretty cool because it shows you that Pony is actually an actor-based language, and the BE stands for behavior. And when you want to work with Pony asynchronously, all you have to do is invoke a behavior. And that's going to be asynchronous. It's not going to return a value. It's going to basically execute that in an asynchronous actor, and that can run concurrently. And since Pony has reference capabilities, you can rest assured that the concurrency is going to be safe if your program compiles. There won't be deadlocks because there just aren't any waits. So we spent a lot of time in the whole Pony session learning to code in this asynchronous way. So I was talking to one of the Pony core team members, Sean Allen, and I mentioned that I worked with Erlang and Elixir, and he said, "Oh, I don't like that about Elixir. Get your synchronous out of my asynchronous." And after working with Pony, the tools are so good that I began to agree with Sean a little bit. I could be doing a lot more asynchronous code in my Elixir because the language definitely supports it. I just haven't been trained to think that way. So here's the actual invocation of one of those behaviors. If you see the c.inc, this basically is going to work fine because it compiles safely, and this is in the inc is going to increment that asynchronous behavior. And you see that c.display is also going to be an asynchronous behavior, and that is going to, if we go back up, that's actually going to display the value of the count, which is a pretty cool design. It's a callback style, which is made safe in Pony because the messages are guaranteed to be processed in the order that an individual actor sends them, which is a pretty cool guarantee. This is an example of an error that you're going to get if concurrency is not safe. You see that counter.value, it said that we can't read the counter through a mutable value tag. So mutable value is one of the actors in my program, and tag is one of those reference capabilities that we talked about. And basically, one of the rules is that if you have a tag, you can't read a value through it. So since I have counter.value, that's going to break. It's not going to compile because I'm trying to access that value in an unsafe way. In the second video, we shifted to problems like this one. We have some interleaving, and you notice that there's a balance that's in conflict between the program on the left and the program on the right because we haven't managed concurrency very well. And Pony's answer to this is something called the reference capability. And we looked at briefly what each one of those are, that we control references in 3 different dimensions. The first dimension is reference sharing, so the ability to send a reference from one actor to another. The second one is the ability to create aliases. So it's not enough to just control a single alias. You also have to control other copies of it throughout the program. And the last thing that we tried to control was mutability, the ability to read and write data. Mostly at the same time, but you'll see that other reference capabilities don't allow either reads or writes, and we'll talk about why that makes sense in a second. So the ISO reference controls the ability to assign aliases, other aliases, thus keeping this particular reference effectively in isolation. So there can only ever be one copy of an ISO around it at any given time. The second capability is val, and you can notice that all of these capabilities relate to read-only references. Vals don't allow writes at all, so you can send them and you can create other references, because if there's no read-write, there's no mutability problem and there's no concurrency problem. So if you can both read and write, then we have a problem. And you saw that ISOs control this by allowing just one reference at any given time, but you can see the assignment on the lower right is green, and that means that it's allowed by Pony. What's not allowed is the ability to send this reference to other actors. So if we keep this reference in one particular actor at any given time, well, things are serial within that actor, so we should be safe. And the last reference capability is the tag, and this is used to basically present a public-facing API that can only be accessed through its behaviors. So in this case, we don't allow reads, we don't allow writes. The only way that you're allowed to access these basically actors is through message passing. So we allow them to be sent, and we allow other references to be created with impunity. And once we do this, we can build this into a Pony type system. So you see that a type declaration includes both the type and a ref cap. An example is maybe we have something dangerous. It's a U32 integer, so we put that in isolation with ISO ref cap all the way on the right. Maybe you have something that's writable, and so we make that a ref to control. Essentially, we put things in isolation by not allowing to have them be sent. And then read-onlys, these we can control by controlling the mutability with a val ref cap, and tags don't allow either one of these. And that's what we covered in Chapter 2. We're picking things up in the third chapter that you got from Pony. And one of the things that you learned was about the syntax, the syntactic sugar, and the partial applications and the promises. And these all work together to allow us to do request response type programming. It's pretty cool. So in this program, I have a counter, and one of the things that I want to do most often is increment the counter. So rather than calling this function increment, I call it apply. And that means that when it's time to actually invoke that behavior, all I need to do is omit the apply and just say C, open and close parentheses. And this isn't a huge deal in this program, but in a lot of Pony's more advanced elements, there's a lot of noise when we're calling the main functions of things like promises and partial applications and things like that, if I code an apply, I can really shorten those things up. So for example, array access is done this way. Hash map access is done this way. The fulfillings of promises. So the language actually has these cool little bits of sugar that make what's happening a lot more pleasing to the eye, and the structure is just a lot better. So apply is one of those things. Another thing that is unusual in Pony, well, not really in any language, but in object-oriented languages, we have this idea of partial application. And the way to think of it is we can build a function out of an existing function. Like in this example, we have this function called add. And what's interesting is that this has two arguments, and these arguments are named X and Y. And with apply, so this is the class math, and we can take math and use this tilde, and this is the partial application operator. And we can say, I'm going to apply only one argument, and that's going to build me a function that is going to add and substitute 1, so it'll add 1 to whatever I pass in. And what's cool with Pony's syntax, or with Pony's partial application, is I can apply either the first or the second argument, or I can apply both and leave the function uninvoked, or I can apply neither. So those are all pretty cool implementations of the apply. And we actually started working with apply in what's really pretty much just beyond an introductory Pony course, because we wanted to be able to use this feature called promises. And let's take a look at how a promise works. So effectively, I have a program where I want to say, go 2 steps forward and 1 step back. Well, the way that we implement this in Pony, since these are behaviors, is a little bit awkward, right? Because forward is not going to return to allow me to then call another forward and then call another back. So how do we do that? Well, we do that with a promise. So in this case, I have this promise, and the way to read this is a promise that is going to be fulfilled with the U32. And we're choosing a U32 because that's what my steps are using in this program. So when it's time to chain these ideas together, I can do so. And this is how it works. So basically, I have my stepper, and the stepper is just this actor right here. And now I can use Pony's chaining that looks like this. So rather than returning forward, we know that this is asynchronous. But since I'm using this operator, which allows me to send repeated messages to the same base, I can say stepper, send the forward message, send the forward message, and then send the back message, and then send the get and pass a promise. And when it's time to fulfill the promise is going to be fulfilled here with this apply function. So this means fulfill the promise and trigger steps. And that would be all there is to it, except promise also has this next function. And next means I want to take this next. So when this promise is fulfilled, I also want you to fulfill this function. And this is a partial application. This is this current actor, and fulfill is this function right here. And that function prints the result right here. So what's nice is I get this very pleasing flow like this with the composition, and then I can get this request response style API with this right here. And even though this isn't the reference capability that I need, I can convert it to one based on some rules that you'll learn in the second chapter if you haven't gone through it yet. So this is how Pony gives us this beautiful asynchronous model and yet allows us to connect things so well with the idea of the apply sugar, the partial applications, and this library of promises and promise chaining, which allows me to connect one or two of these together so that when the promise fires, then I can decide to fire another message, and I could even have a chunk of these next functions one after another if I wanted to. And that's pretty much the focus of the third chapter. So now that you're in the fourth chapter, I want to walk you through another couple of things. I don't want to show you the whole implementation of the TCP/IP server that you're going to be working on. You'll get that in the project. What I'd like to show you is just a couple of pieces of not the chat room, but the chat client. So I think that this is probably a pretty good representation of the way that Pony works with asynchronous processing using predominantly a callback model. So as a good example, I have this, and here's the promises again, and I'll show you where they come into play. I have this terminal handler right here. Is that where the promises come into play? Yes, this is exactly it. So basically, this is a terminal handler, and there's a little bit of ceremony to wire that up with a terminal notifier. But eventually, what's going to happen is new keyboard input is going to come in through apply here. And when I get new feedback, I can decide what to do with it. So one of the things that I get is the message that the user has typed. So the user is typing chat messages, and one of the things that they can type is a regular message, right? So, hi Bruce, how's it going? Hi Sean, you're my best friend. Sean, shut up, I barely know you. Then I can also get the prompt, which is a promise. And the way this works is if I type quit, if I'm done chatting with Sean because he told me to get lost, I can type promise or prompt.reject. So this is a promise, and rejecting this in our sense is going to start the machinery that shuts everything down cleanly. And if I don't want to shut things down cleanly, I can keep working. I'm going to fulfill that promise instead. So in this case, when I type a chat message, I want to write that message in a specific format to the chat server, which will send it to the room, and then the room will find all the users that are in there, we'll iterate over them, and then we'll use an object that we have called a session to broadcast those messages out to individual users. And then it says set the next prompt. And when I set the next prompt, I'm actually fulfilling a promise and saying, okay, you can go ahead and keep working. And then, there are also some goodies built in, like if I want to do tab completion, I can do that and basically build this list as I go. But in our case, all we wanted to do was be able to quickly recognize quit. So that's all I have in the tab completion. But this gives you a good sense of how Pony programming works. And so if I look at the netclient, this is going to look very similar. This again uses promises, and we're going to fulfill promises when we rarely need that request response style processing. We're going to create this thing, and that is basically going to set up a notifier that gets called when important things happen with TCP/IP, right? So if a join is successful, I want to send a message to the chat server that says, hey, join this email to the chat room. Or if I receive input, I want to print it out because that's the purpose of the chat server. So if there's something that's broadcast, it gets sent to all the clients, I read it all, and I can print it here. And this consume is basically a way to say, hey, I know I have this reference that's going to be problematic because I've used it in this way. So what I want you to do when I'm done is burn this reference. I can have one client using this kind of reference at a time, which is sometimes exactly what Pony needs, like in this case. So it's like passing a baton from one reader to another. And then I can also have a connect failed. I'm not really handling that here. Gosh, you could say that I'm leaving that as an exercise for the user. But once we do that much, then there's really not a lot left of the program. There's the main, and the main's job is within this big fat try to connect to the server with, maybe I have this default email, maybe I have the name, which defaults to anonymous, and then I'm going to build a TCP connection, and I give it the right authority, and then I pass this client handler that you saw earlier, and then I establish the read line loop, which basically looks at the terminal handler that you saw earlier and starts spinning up this command line processor. And this is a little bit of ceremony, sure, but what you're guaranteed when you get this program is once you compile it, you know that you're not going to have the day wasting, the week wasting types of bugs, which is really, really important when you're building certain types of commercial systems. And actually, it's becoming increasingly important when you build all systems. So gosh, if I weren't so invested in Elixir, which gives me some of these capabilities, not the safety, but the reliability and robustness in other ways, I would really be looking hard at Pony right now. So that's all I've got for chapter 4 and the wrap up. So I hope you've enjoyed what you've seen in Pony language. And I hope you'll really check it out, and that if you decide to use it, that you'll go ahead and help out the ecosystem. You know, there are things that you could do with the documentation. You can make videos like this one. You can write a book. You can even do things that make money in the ecosystem. All of these would be very helpful to the people in the Pony language. And I hope that if you like this one, you'll stay with us in the next phase of the Programmer Passport. The next 3 languages really 2 languages in the programming paradigm, are going to be a Joe Armstrong celebration. I think you're really going to like it. Joe was a big fan of the Prolog language, and in fact, that's how we met and became friends. And it's actually how I got my start in loving programming languages and establishing 7 languages in 7 weeks. And that's actually what formed the root of the Programmer Passport. You know, there's also some great things that you can learn out of Elixir. Even if you're an established Elixir programmer, we're going to have a lot of exercises, and we're going to cover some of the edges. With a 4-chapter approach, we can play with some of the things like binary pattern matching and some of the rough spots that we all have in a language that we love. And if you're new to Elixir, you're really going to enjoy it, especially if you like the Pony language and if you get into attacking concurrency in a way that's safe and robust. And then we're going to look at OTP, and that's going to give us an alternative view of how to handle concurrency. And wherever you come from, that chapter is really going to speak to you, because that's increasingly where the world is going. And in general, Programmer Passport is about getting better as a programmer, no matter where you are, and having some fun along the way. We hope you've enjoyed this look. Take care.